Ladies and gentlemen, right now we have Sergey Nazarov for you. He's going to be talking about smart contracts, and so I, for one, am pretty interested in to see what he has to say. Thank you.
Great. Thank you, everyone, for coming. So today we're going to look at what smart contracts are, how adoption is likely to happen, what's stopping adoption from happening, and what we as a community can do to improve the chances of adoption in the near term. So a smart contract, as many of you know, is a better form of digital agreement. It's basically a trustworthy form of digital agreement that guarantees certain execution. Basically, when two businesses, big or small, if individuals want to execute a contract, in today's systems, they can't be assured that the contract will execute. Whereas in a smart contract scenario, they will be assured, or they should be assured, that as long as the contractual conditions are met, the contract executes. That's a pretty big shift in how digital state works and digital agreements work, and it's something that, for this reason, is termed possibly the main use case of blockchains. Like, for example, Bitcoin multi-signature is a smart contract. That's a very useful, interesting feature. Lots of dynamics that you see in tokens use small amounts of smart contract features. So this is really the body of work that I've always been very interested in, is creating contracts that are reliable and that basically guarantee that if somebody performs, they get what they deserve. That's I think, an interesting and worthwhile dynamic that is worth it to pursue, generally speaking. But to understand how that can happen, I think, at least in my experience, it's been very useful to look at what a smart contract would be replacing, right? To understand what the competitive dynamic is of how does it happen today, how will it happen tomorrow based on these new features, why are they important, why haven't they been adopted yet? And so the first step in that process, in my experience, is usually understanding where the problems lie in today's systems. So in today's systems, if two companies, big or small, or even individuals, would like to do a contract, most of the time what they do is they use a service. They use a centralized service for all types of transactions. Securities transactions, trading transactions, global trade. They use something that has a digital contract that sits between them. And that digital contract is run by a company. Now, they basically don't exactly trust that company 100%. That contract might not execute properly, and that might mean that they don't get what they should get. So they keep redundant copies. So now we have both parties using a service, and we have them keeping redundant copies across their different departments. Then they also have to keep the contract updated with all kinds of data inputs and all kinds of other points in the contract, because many of the systems don't do that, and the responsibility falls on them because they don't necessarily trust the system that they use for the contract to do that properly. Then they need to execute payment, and they need to update both the system and all of their systems. And then they also need to go and talk to the government. They basically need to let the government know what they've done with the contracts that are regulated, right? This is basically the world today, and it's a very complex world. It's a very high-cost world. It's a world where if I wanted to start a certain type of company related to securities or insurance or trade finance, I need a few $1 million. I wouldn't be able to get the systems that I need running in order to run a certain type of company because of all this complexity, right? Because what most insurance companies do, securities, a lot of other big industries do, is they basically execute digital agreements, right? And they have the systems to do that in a way that is considered reliable by all the parties involved, right? So this is extremely high cost. Now the world that we're going towards is a world where it's greatly simplified. It's a world where there's basically a smart contract, which is smart as far as everything that it needs to be smart about. It knows about all the data related to the contract. It knows about all the payments that happen because it executed them. And it's a trusted mechanism that both parties can rely on completely, to the point that they don't even necessarily need to keep redundant records across departments, right? Their 4 departments can all look at one record, and it's not a wacky internal record they made up. It's just like the thing that everybody looks at. The regulators, even the public, right? So the public can even conduct oversight on certain things that affect the public, like financial markets and other important things like that. Now, this this world does two really interesting things. The one thing that it does is it basically greatly depresses the costs and increases the transparency of how financial markets and insurance markets and a lot of these markets work, to the point that they work a lot better, which helps all of us to a great degree, right? Like, if this is how the world worked in 2006 and 7, you probably wouldn't have had the 2008 real estate debt crisis, because everybody would see what was happening. It would be easy to evaluate each individual contract on the level of each individual contract holder, right? That was the opaqueness that caused that problem, right? This opaqueness and complexity. The other great thing that it does is that if I wanted to start a web company 20 years ago, I needed a few $1 million. Today I need a few $1,000s, because there's a great simplification of web infrastructure. Today, if I want to start something in insurance or securities or some company that deals with high-value complex contracts, I need a few $1 million. But in a world like this, I would need a few $1,000s. And that is very important for both innovation here and especially in emerging markets, which might not have certain things at all. So that's the general picture of what I think the world is moving towards. Now I guess we can now that we see this picture, we can switch to how do we get to this world, right? What are the hurdles to getting to this world? Now, traditionally, when you have new methods of software delivery, and there's really been 3 or 4 shifts, but the most recent shift has been you had on-premise software. So you had people buying servers and you had them stored in the basement of their company, and that's how they consumed software. That cost millions of dollars. And then you had software as a service appear, right? And initially, when software as a service appeared, there were a lot of people that said they would never use it, right? They said they would never give their data to an application that isn't in their basement, right? Because at that point, everybody had not a mainframe, they had a whole set of servers, and they kept all their data in their company, and they processed and had software that was just run in their basement. That's just the way the world worked, and it was extremely costly, and so it was very difficult to do anything in software. But at the end of the day, software as a service basically won out. Right? Basically, right now, when I want to build something, I use platform as a service things. When other people want to build certain products or use services for even accounting or anything else, they don't get a server and put it in their basement. They use a web service, right? Now, this, according to Mark Benioff, which is basically the guy who led the charge on software as a service implementation at the large scale, or at the tipping point level of taking it from an interesting idea that's probably not going to happen to, like, what is going to happen. He basically, according to him, this is the recurring, consistent concern that he saw. Right? The concern was people don't want to give up control. They were just in a panic about giving up control. And that's a genuine concern, right? I have a certain level of control. Why should I give it up? Now, the answer for why people gave up control over their records before was basically that the value was there. There was sufficient savings on cost, on usage, on speed of implementation. There was basically a feature list. A feature list that for every person was different, but it grew to the point where the risk of giving up control over something became overshadowed by the reduction in cost, right? That's what people call the SaaS tipping point. When you reach that level of features, that for the majority of people it overshadows the cost, then people begin to adopt in large amounts, right? So I think it's a very similar question for our community right now. The question is, how do we get to this smart contract tipping point? What is the set of features we need in order for adoption to go from, it's an interesting idea, but I don't want to give up control, to, yes, I want to turn my insurance company into a smart contract powered business. I want to turn my bank or whatever I want to build as a startup or whoever, this has sufficient value even though it has certain costs and risks, right? Because it's not riskless. There is, whenever you transition to a new delivery method of software, you lose something and you gain something, right? I'm basically saying you have to gain enough to make this happen, right? So that's the enterprise which I feel, you know, that we and our team are engaged in. We're very interested in seeing this happen. We're very interested in seeing the features appear that are necessary for the tipping point, for smart contracts to become more useful than they are risky, basically. Now, if we look at the actual problems that people have, they basically have three problems. They're basically three features missing. Feature number one, the most immediate feature, is connectivity to key resources, right? The fact that a contract needs to be able to get data, needs to be able to send payment, needs to be able to know what's happening relative to the points of the contract, right? The second point is a question of privacy for the contract terms, because a lot of times people don't want to really reveal privacy. And the third question is scalability of the system in which it'll function, right? And we're just going to cover each of those questions one by one. So the first question that we're quite focused on with our work implementing oracles is basically the question of there not being an ability for a contract to connect to resources. So this isn't as widely known, but at the end of the day, the contracts on networks like Ethereum or Hyperledger or really any other network or any other truly decentralized tamper-proof smart contract network are unable to get data, and they're unable to get access to payments. This is a huge limiting factor, right? Like, imagine if you tried to build a web application 10 years ago without access to certain data. Like if you tried to build Uber, right? If you tried to build Uber and you didn't have GPS, and you didn't have the ability to send an SMS, and you didn't have the ability to send payments, you'd have to build GPS, SMS, and payments. And then you'd have to build Uber, right? That's the situation today, right? The situation today is if I want to build something like Uber, I have to build I have to build middleware, which is very complex and has a whole different set of security problems. So the first problem we're very focused on solving with ChainLink is the question of middleware. It's the question of how do I get a contract to talk to a data feed? How do I get a contract to send payments? How do I get a contract to do off-chain computation about the data it acquires, right? Because without all of these inputs and outputs, it's going to be very difficult to build a contract that does anything other than tokenization, right? And 80 or 90% of the contracts in the world go beyond ownership. So, that's really what this seeks to do. It seeks to take smart contracts beyond tokens and bring them to a place where they can be complex, as far as knowing that something happened and being able to pay for that happening. Now, the ways to do this are varied, and there's basically two approaches. The first approach, the one that's come into existence initially, is the ability to just build a service, right? To build a centralized kind of SaaS service that does this. It takes some data from somewhere, it passes it through some servers that I run or somebody else runs in their basement, and it gives it to the contract, because the contract can't get it on its own. Now, okay, that seems like an interesting idea, but if we think of the value of the contract, we start to see some flaws, right? The value of the contract is that it's tamper-proof, is that it's guaranteed, is that it's reliable, right? Is that it can't be stopped, hacked, tampered with, it's secure, any of those synonyms, right? And we're going to be triggering that highly secure contract run on thousands of nodes by one node, right? Now, yeah. So we're going to be triggering that one contract with one node. That doesn't really make sense, right? If I'm putting a contract in an environment where I trust it because it's executed on thousands of computers, and then I go ahead and I execute my contract by one node run by a startup, that doesn't really look like a contract I'm going to put $100 million into. That doesn't look reliable, it's quite easy. It's difficult to go after a data source because they've been around for decades and they know how to secure their systems. It's difficult to go after the smart contract network because, by all apparent indications, they seem to be working. But it's quite easy to go after a service of one node run by a few people, right? So this is the way to do something like this today, and it's problematic because it doesn't provide the guarantees that you would want provided for a contract, right? It makes the contract insecure and unreliable. So the solution, in our opinion, is the creation of a decentralized method of doing this, which is basically a decentralized Oracle network. So just like the mechanism for executing the contract logic is decentralized and therefore reliable, you now have a decentralized and therefore reliable mechanism for delivering data to the contract, right? And once you decentralize this layer of data delivery, you can then decentralize the layer of data acquisition. You can decentralize the data sources, right? It doesn't really matter if you have 3 data sources going into one node, just go after that node. But if you wanted a high degree of reliability end-to-end for the entire contract, you would, within the logic of our space, want decentralization end-to-end, as far as you could get it, right? So you would ideally want decentralization on the level of the data, however many data providers you feel you need, and then however many Oracle operators you feel you need, and then they, using these decentralized methods, send that data to a decentralized execution environment, which is the smart contract network. And now end-to-end, you have a tamper-proof, reliable contract, right? Not just in the middle, but end-to-end. Because if somebody's going to put money into this thing, they're going to look at it end-to-end. Nobody who has $100 million to put into a contract doesn't look at things end-to-end, right? So the next portion of what we do, the next most requested and most useful part of this middleware problem is basically the ability to do payments. It's the ability for smart contracts to generate outgoing payments to all kinds of payment systems in both the retail and institutional environments. So in this scenario, you would have a contract that is reliably triggered and a contract that can pay to the accounts that people want to receive payment in, right? These are the qualities of a complex contract that can compete with existing digital agreements that aren't decentralized, right? Now, the focus and the goal of our work is to basically aggregate all the building blocks and all the resources that a smart contract would need in the near term and make it easily available to them, right? The goal is that just like a web developer could show up and get an API for GPS, for SMS, and for payments, a smart contract developer can now show up and he has a large list of basically oracles or ChainLinks that represent various off-chain resources. And he can write his smart contract code and he can connect it to all these resources very easily, and so he doesn't need to worry about that piece anymore. Right? And the thesis is that once smart contract developers are able to quickly combine all the necessary resources of inputs and outputs around the contract that they decide to write, then you will see many more complex contracts that go beyond tokenization, that do something, something like an insurance contract does, something like a securities contract does, something like a trade finance contract does. The trillion-dollar industries that power the world, right now running on digital contracts, right? So we need to get this technology to that point by giving developers the building blocks they need to build those complex contracts. On the 3 problems I mentioned, the initial problem we're going after is connectivity. Privacy is also partly addressed because part of the agreement can be off-chain, and scalability can also be partly addressed by an oracle because oracles have off-chain computation capabilities. At this conference, I'm very glad to say that we have made, over the past couple of months, we've made substantial progress towards this. And basically, we set a deadline, and we wanted to announce here that the initial implementation of the ChainLink node has been put out this weekend. Thank you. Yeah, we've been working on that all the time, basically. And Yeah, so that initial implementation is out with a lot of the core features that the ChainLink network will need to function properly. And if you'd like to know more beyond what the ChainLink node does in a very technical sense, you can look at the white paper, which provides a general overview of kind of the problems that we're working through. But if you're a developer, we encourage you to look at the ChainLink node, and if you are writing contracts, we encourage you to try and, if you need an external input like data feed, or you need an external output like a payment to a bank account or somewhere else, we encourage you to try and give us feedback. And it's completely open source under MIT, and we're excited to hear everybody's feedback and work with with the larger community to solve this problem. So
you have about 3 or 4 minutes if you want to take some questions, or if you want to finish up, or whatever. It's your choice.
Yeah, 1 or 2 questions, I guess, would be fine. Yep.
I have seen that the integration is very easy with web service, with software, with SAP. It will be very easy to integrate with the smart contract. What I see is very hard to be integrated is the banks and the retail Visa. How you are working with them, or who is working with banks and retail payments processors to allow this?
Right. So the goal with payments processors and the underlying banks is that we make it easy for them to provide an interface. Right. We take the technical burden off of them, so they can provide an interface very easily. When you're going to be doing bank payments or any kind of traditional payments, what the payment processors and the banks are going to do is they're going to do a lot of, well, not a lot, it depends on who they are, but they're going to do review of each customer. So the way this would work is that a specific bank or a specific payment